So there are lots of crystals that we learn about in grade 12 chemistry, such as ionic, metallic, network, and molecular. But what I want to do in this tutorial is to explain those three types of intermolecular forces and their strengths that occur inside of our molecular solid. Let's get started. So before I explain these three intermolecular forces, let's talk about what intermolecular actually means, because I get a lot of students getting confused between intermolecular and intramolecular. Intra is within, so within a molecule, right? Like your covalent bonds. Intermolecular is between, so between molecules. So for example, if you have two water molecules, right, what is holding them together? For example, in an ice crystal. Now, our first type is called London dispersion forces. These will occur inside of nonpolar molecules. So for example, here I have an oxygen molecule, so O2. So we have a double bond, that's an intramolecular. They're your covalent bonds within your O2 molecule. But here I have another O2 molecule. So what is causing these two molecules to attract? What is this force? This is a very, very weak force because a London dispersion force is a sort of random instantaneous dipole that occurs within the electron cloud around your oxygen molecule, right? So the electron cloud isn't exactly static, right? Your waves, your electron waves are moving, and you can get a sort of random distribution where at any instantaneous moment you have one side of the molecule being slightly more negative than the other side. So you get a very, very weak negative and positive dipole forming around your molecule. The same thing can happen to another oxygen molecule, and therefore they can align themselves so that the negative side of one molecule is attracted to the positive side of the other. Again, this is very weak, random, instantaneous, and so these forces are extremely weak. However, if we have a polar molecule, like hydrogen chloride here, this is a polar molecule. Okay, you can determine that it's a polar molecule, one, because it's very asymmetric, it's not very symmetric, and two, because that bond there, that intramolecular covalent bond, you can check its electronegativity difference and realize, yes, that is definitely polar. So this is a permanent dipole, where one side is definitely more negative than the other side. So it's very similar to London forces, but it's more pronounced. It's a lot more pronounced. And so these are called dipole-dipole forces, where we have these permanent dipoles where one negative side is attracted to the positive side of another molecule. That is our dipole-dipole attraction. Now, if you have a very, very pronounced dipole, right, where the electronegativity difference is extremely high, this is called a hydrogen bond. And this will occur if you have, in your molecule, you have hydrogen and either a fluorine, oxygen, or nitrogen for the most part. So here we have a water molecule, right, where we have water molecules are polar. One end is negative and it's attracted to the positive end of our other water molecule. So this here is a hydrogen bond. Again, they're all basically the very same type where you have opposite ends of a dipole attract, but you have London dispersions, which is extremely weak, dipole-dipole, a lot stronger, and hydrogen bonding would be your strongest intermolecular force. So here are some other examples of hydrogen bonding. Again, typically, generally, you can think of it as hydrogen with nitrogen, oxygen, or fluorine. And so here we have a water molecule forming a hydrogen bond with ammonia. And here we have hydrogen fluoride molecules forming hydrogen bonds. So why learn all of this? How does it help us? Well, let's look at the strength of these intermolecular forces and how that can help us determine properties of these solid substances. All right, so here we have two nonpolar molecules. We have chlorine molecule and an iodine molecule. Okay, they are both nonpolar, so they're attracted to other chlorine molecules will be attracted to other chlorine molecules through our London dispersion forces, and likewise iodine attracted to other iodines. But are these London dispersion forces the same? No, they're not equal. In this case, the strength increases with an increasing number of electrons. The more electrons you have, I guess you can think of it as a greater chance that you have a random distribution that will provide these London dispersion forces. Okay, and because of that, iodine has stronger forces than chlorine and therefore higher melting point and boiling points. Right? If you wanted to take iodine and boil it, you need to break apart these intermolecular forces so that it's free as a gas. To do that will require more energy if those forces are stronger. Okay, what about polar molecules? Okay, so here we have water and hydrogen sulfide. So in this case, you might be able to recognize, that's going to be hydrogen bonding. It's definitely greater, but it's greater because its degree of polarity is greater. Right? We know the electronegativity difference is very high with, like I said, with hydrogen bonding with hydrogen and oxygen or fluorine or nitrogen. Right? And because its degree or electronegativity difference is so much greater, it's the one that's going to have a higher melting point and boiling point compared to our other example here. So in general, if you're looking at molecular substances, look to see if they're nonpolar or polar, and you'll know that your nonpolar is held together through London dispersion forces, which are weak, and your polar are held from dipole-dipole or maybe even hydrogen bonding, which are much stronger, and therefore you'll be able to tell that this one will have a higher melting point and boiling point. And if you're comparing one polar with another, look at the degree of polarity. Okay? I hope that has helped you understand these intermolecular forces a little bit. If you have any questions, you can let me know. And for now, if you want, you can download my entire course pack that I have available for grade 12U physics if you're taking it for free in the description. Check it out, and thanks for watching.